Bunzel, a German, who let's say was looking to the different colors and he made a chart of that in a specific color codes. So sometimes also, especially when you do chemical stabilization, so by adding cement, you know it doesn't work with black soils, it's not going to work. Then you want to know, of course, also the color. Keep also aware in the United Kingdom on the coast, there you can see sometimes that white color that you see, it's actually the range, but anyway. The thing is like, that means most of the time it's coming from the sea. There's a lot of calcium inside. Also, for example, when you are in the Himalayas, it's also, let's say, the rocks, etc. is white color. Also in the past, the sea. So it's being pushed up millions or billion years ago, whatever. In geology, we can miss 500 years, it's okay. It's not a second. Okay, so the colors are important to know. Acidity. Okay, so pH neutral is 7. When it's less, we are in an acid environment. When it's plus, it's a basic environment. Be aware from cement works the best, let's say 8, 9, 10 pH values, it's fine. Cement itself has 12, even 13 as a pH level. Keep in mind you can also get burned with a high pH level. It's not only with acidity. Which is in your lungs and in your stomach. What do you think is the acidity?
High.
High?
Yes.
Two?
2?
2 or 1?
2 or 1. That's not high.
It is, yeah, because it's acid. On the pH scale, it's not high, but if you look at how high the acidity of it is.
2 in your stomach, the acidity is even less than 1. So you need to get all the bacteria out. That's why when you get a little, let's say, gap in your stomach, that hurts a lot, because that's a lot of acidity that comes in your body. Dus de zuurtegraad melden.
Dus, gap in the stomach.
Dat is voor
Sit on the get the gap.
12 en 13. En de zuurtegraad werkt eigenlijk zeer goed voor cement als je rond 7 zit.
Oh, serious? You need to go to the doctor? Yeah. How do you know if you get one? Okay. Yeah. No, not about you. Roll got Mark.
Of course, it always
Yeah, but that's also good to see. But on the pH scale, the lower the number is, the more acidic it is, right?
Alright, so and if you
Yeah,
drink
but the lower the
Coca-Cola
more acidic.
with your stomach, the acidity is even less. So when you are in an area where it's not good food, and believe me, I went to many places where the food was not really good, project sites, then I was very happy with my Coca-Cola, because then at least I could keep walking. Because you can get a lot of bacteria inside, but you don't know, and if you drink Coca-Cola, it kills everything. Nice. So, but don't do Coca-Cola Light, because then you get the double of bacteria in your stomach. You are aware of.
But when you feel bad, you have to cleanse it.
Just
When you feel bad, you cleanse it.
as a small tip. Coca-Cola, very good. Sounds like a commercial.
Coca-Cola.
Is that mine?
Okay, water permeability.
We really want it.
As we all know, water permeability, the ability of a soil.
So they've
water
given
can
it if you
percolate.
really want it.
Percolate is a word that we use for vertical going downwards of water. Horizontal, we call it drainage. So you know the difference. Percolation, keeping the soil, horizontal drainage. In between, you can choose. Okay? Doesn't matter too much. But that's the difference. Now, difficult test, no. You have a soil, you put water on top, and you wait until it goes down on the other side. So it's just like psychological exercise. Dus mannen, water doorlatendheid. Dus dat is een mogelijkheid om water door te laten gaan.
If you really want it, yeah, of course.
Water gaat 40 graden naar beneden gaat. Dat noemen we percolatie. En horizontaal noemen we dat drainage. Here you can see some permeability factors. So clay, it's like the speed of it is like 0.0005, and you have also clays which less meters a day. So to get like, if you want to see water going through clay for 1 meter, then you can see how long you have to wait. It's approximately 200 days. So you need to take something, some Coca-Cola with you to drink. And then if you have gravel and so on, that's going to like this. But you all know that, because that is very simple. En dus gewoon water doorlatendheid, maar met gravel en zand die dat gebruiken ook voor water weg te draineren. Heeft een goede doorlatendheid, dan gaan we dat gebruiken. En klei, dat duurt 200 dagen bij zwakkere kleisoorten, dat dat water weg is. En een beetje geduld. Okay. That's actually the problem. What we have sometimes when they say the groundwater level is very low, and then it's raining like for months, and the water is like a half a meter and a meter high. You get an inundation, and then a few days later there is a somebody who does geohydration, hydrology, excuse me. Then what happens is that you have, nobody understands this very well because there was 1 meter of water, you have floodings, etc. And then this guy is saying, the groundwater level is not good. We don't have enough water. But the problem is, of course, it's clay. That water is not getting to the groundwater. And it's going to the rivers and it's off, it's gone. There are some laws which say you cannot percolate rainwater to the subsoil because you could make some holes in the soil to get it to the sand layer beneath. But the problem is that rainwater can be, let's say, contaminated, and then by law it's not allowed to induce rainwater into the groundwater, because groundwater we use to drink, and with rainwater we're not sure about the quality sometimes. That's why we cannot put it in. But for many people it's like strange when they say like the groundwater level is actually still not good enough. Because of the clay layers goes up. Dus van dit jaar waren er wat overstromingen. In België ook vooral in de IJzervlakte. En dat is een kleine grond. En dan hoor je daarna de mensen zeggen, ja, de grondwaterstand is steeds niet hoger geworden. Dus dat hier allemaal een meter hoog. Maar dat komt natuurlijk als dat klaarwater is, moet dat water niet naar beneden. Dat is niet waar. Dus dan zitten er al 200 dagen hoog water in, of dat erop staat. En dan is die een metertje doorgetrokken. Dus nu ten hoogste zal dat misschien 10 of 15 centimeter zijn, en dat is het verhaal. Wat boeren wel kunnen doen, is natuurlijk goed ploegen, dat er wel een water kan niet tegen. Ja, capillariteit, dat kan we goed zeggen. Then we have the capillarity, and capillarity means like the ability that water is being pushed upwards. Due to the, let's say, the fine pores, water has the ability to go vertically upwards. It's like the same when you have a straw and you drink something, then it's very small, you create a vacuum and it comes up. And with clay you can see the groundwater level can be minus 30 meters, but still it can reach the surface. But you have to be aware also, when you are closer to the sea, you can also get salt water upwards. And that's something what we don't like, salt water, because then nothing can grow there anymore. So we have to make sure that rainwater, which is sweet water, is always floating on top of the salt water that is being pushed from the sea. So we just can't just drain out all the water out, because then the sea just brings salt water in. And the problem is then no agriculture, no green anymore, a little bit of desert. That's what you see also sometimes in Namibia and so on, the African coast. There nothing can grow because it's all sand. If it would rain, it goes down, and there is no capillarity because it's sand. So you can see the sand, 0.3, it's only 30 centimeters and that's it. And if that comes up, it's only going to be salt water. Dus je moet een onderscheid maken. Dus capillariteit is gewoon die fijne deeltjes, dat trekt de kleren een vacuüm. Dus dan heb je een stuk verschil waardoor het al water naar boven kan. Een klei is zo fijn dat dat zelf tot 30 meter hoog kan komen. Daardoor, in de landbouw, door goede kleigrond, is dat eigenlijk altijd vochtig. Je kunnen er altijd planten blijven groeien in de grond. Maar als je natuurlijk al dat water, dat regenwater zou wegtrekken, dan komt er zoutwater en de zee naar boven. En zoutwater, dan kan er iets meer groeien. Dus dan moet altijd naar gekeken worden, dan is het iets. Oké? Alright. Then the Proctor test, that's a test you're going to do. With the Proctor test, basically you go to see with what amount of water you create the optimum or the maximum Proctor density, MPD. And OMC is the optimum moisture content. So basically what you're going to do is like when you have a soil, and you know you add some water to it, then you can get a higher density. Most of the time you have, let's say, like this type of curve. So basically what you have, you take a soil, you add some water to it, you start compacting it until the cylinder is full, you measure the density, so you have a certain density, then you take a part of that soil, you measure the mass, you put it in the oven, and after that you measure again the mass, and then you know how much moist was inside that specific density, and that you put on the x-axle. You add some water, up and again, until you get a nice curve. And then on site, later on when the project will be executed, you have to say, you have to put a water content of the soil of 8% or 10% that you can compact it well. If it starts raining that day, you don't want to add water, please. Yeah? And if it's very dry and you have to mix it, add a little bit of extra water. Therefore, you need a little bit experience. Yeah? Oké. Dit is belangrijk voor jullie, voordat je erover denkt. Is dat je daar op de x-as zitten we het vochtgehalte
Let's shake
en
it.
op de y-as zitten we de dichtheid. Dus wat je gaat doen is je mengt de grond met een hoeveelheid water. Dan ga je dat goed verdichten. Dan ga je
Should for the
het
mechanical engineers.
volume beter van die cement dan je vast. En dan als we dat gewogen hebben, dan gaan we
Should for
kijken
mechanical
een beetje
engineers
grond.
fix that for me. That little
En
project.
vervolgens gaan we de massa ervan wegen. Zitten dat in de oven.
Industrial engineering.
That's industrial? Isn't that mechanical more? Put it up.
It's about standardization, so it's more specific. Statics.
Move to the helm.
There's
Yeah.
also
First of
materials.
all, we need to dig a foundation on it. Insert pillar.
They're insanely small.
Yeah, used to be a lot of mechanics.
There's more
Maybe that guy is smart. Maybe that one guy is smart.
maybe.
You know, smart people. People opposite.
Zeer kritisch, want je ligt een piek. Je staat maar zo
I'm
lang
sorry.
in de klei. Als je dan hier of minder iets hebt,
I said opposite attract each
het
other.
begon te regenen, dat is hetzelfde als een douche. Dat je gewoon in een douche
Dat je
staat,
dan zo
het
met
zal
smart
regenen,
people.
hetzelfde, en dat is niet erg, want dat is klein, dat water stroomt af, dat komt niet in de grond. Maar als dat zandgrond is, dan kun je best nog afschoten. Dat je niet zo net, kun je toch niks meer in zo'n 2-3 dagen. En dan liggen we gewoon een zeil.
I'll get 8 on everything.
Dat dat licht niet nat wordt, want anders komen we niet.
That's my goal.
En ik Ik heb meestal geen zin
En if I have a goal.
te zuiveren als mooi.
Who attracted them? You or me? Or more?
Hmm?
Okay, so regarding the
Who attracted the other?
yes.
I think I did.
Can I just do it first in English and then you can ask a question, or do you? So first, when you have different soil types, yeah, which soil type do you think is more sensitive for the amount of moisture, and which one is less sensitive? Who thinks his clay is more sensitive?
Amount of moisture.
Yes, to get the optimum. Who thinks the opposite? If it's good, I can now see all the fingers going up. Only two. Okay. So you think that sand is more sensitive for moist,
No.
for compaction?
Sand?
Yes,
Should be.
it should be more sensitive than clay.
For compaction, yeah.
Okay, and why?
Because the sizes of grain sand, the grain size for sands are bigger, and they have more spaces in between and shit. They should be more compactable than clay.
More compactable than clay. Yeah, that's true. You can compact it more, yeah. But is it more sensitive when you get a higher moisture content or a lower than the optimum?
That I don't know.
That you don't know. Okay, very good. Okay, well it's simple. Yeah? If you have clay soils, yeah, the density will be less, but the water is not going to get to the clay that easily. Okay?
Yeah.
When you have sand, it can be more easily being oversaturated, which means that for sand, you have to stay between, let's say, 7 and 10 in moisture, because you get a quite high density. Yeah? When you were playing at the sea or at the beach or at the lake in the past and you build a castle with sand, if you add a little bit too much water, it went off, and when it's too dry, it doesn't work also. With clay, due to the plasticity of it, we have, let's say, a bigger range. You can be between 12 and 20, so, and still you get optimum compaction. That's what I was telling to the Dutch students when I was in Saudi Arabia in the past, and we did their projects for highways, etc. To compact it, yeah, the moisture content should be exact. Because if it's like 5% less, it's like you can't compact it, it's not good. Now, there of course it's a little bit dry, you just crush it open and 5 minutes later it's dry. So that's the advantage of those countries, let that be clear. But for example, when you are in a rainforest in Ecuador, there is, for example, you have a very fat clay, and when it rains, it's no problem, because that water cannot penetrate through the clay. So we just go over with a compactor, so that the surface of the clay is sealed off and there is no water going in. So when the rain was gone, you start mixing again and you can continue with your project. It is less sensitive than you would have it with sand. If you would have there a sand embankment that you have to compact, then you put a layer of plastic over it to make sure that the water goes off, because otherwise you can't work for a few days. Yes?
Explain how to get your craft, add water.
Yeah.
But then first of all, you take it
Dry.
dry,
Yes.
and then you keep adding moisture.
Exactly.
I just don't understand why you keep adding water.
To get that curve, you need to go to a certain moment, you add some water so you get a higher moisture content, you get a higher density. Yeah? And at a certain moment, if you start adding too much water and you put the dot on the screen there where you have the y-axis of the density and the x, then at a certain moment you will notice, oh, the density is going back down again. That's why we do those different points to make that curve possible. Sorry? Like when you were a child, you can feel it. It becomes, if you put a bunch of water in it, yeah, then it's too wet. But you will notice it. You start a little bit dry, and then you continue. And if you get a lot of experience, you can say it at the percentage exactly by feeling it. But that takes a little bit of time. So sometimes when I walk behind the recycler, and I could make like this, and then I could say add 2 or 3 liters extra, so it's mixed into the soil. But that asks a little bit experience. Also, you have to check the wind, you have to see the sunshine, because it takes a while between mixing it in and compaction. So you have to think also it has to stay 1 hour open, so add a little bit extra of water because it's going to evaporate also a little bit. But that's, don't be bothered with that. Most important part is that you know the effect of water and density, and compaction is extremely important. Not compacted soil is a weak soil.
Why does the density go down at some point?
Sorry?
Why does the density go down?
Because if you add too much water, you start filling the pores too much with water, and then when you compact it, the water is going to be squeezed out. That's the difference. Okay? Because what we do with the density, that's a dry density, we do minus the amount of water that we added in the soil. That's why you get that curve. Okay. So this you have to read one more time. Blah blah blah. Here you can see the clay soil, poor density. You don't like that, the dynamic is static. Not good soil. But you can see the water content. Yeah, you can get, let's say, more or less the same results between 10 up to 18%. You're still in a range that you're good, and with sand, you have to be more or less exact here in between, in the top. Otherwise, the sand is not good. That's why it's very crucial when you have to do compaction of sand, you have to do it with nice weather. Okay? Actually, for civil engineers, it should always be nice weather. Personal opinion. To be aware with sand, it's very important. The consolidation coefficient, you saw like this type of machine in the laboratory. With the consolidation coefficient, we're going to check how much the water is getting out of the small particles. Dus mannen, even ter herhaling. Heb je opgekomen dat het hebben begrepen? Consolidatietest gaan we eigenlijk testen hoe lang duurt het voor het water weggeperst wordt uit de kleideeltjes. Dus dat water plakt tussen die plaatjes. En dan met een gewicht erop te zetten, hoe lang duurt het voordat dat water weggaat. Dat doen we met een consolidatietest. Want dat kunnen we ook later inschatten, hoe lang duurt het voordat de grond volledig gezet is. Okay. Dat is een consolidatietest. Okay, so with this test we just check how long it would take that the water gets out between the little plates of the clay particles. Yeah? That is what we test with this machine. We hang a certain amount of weight on it, so we can test, depending of the weight, do we see difference in the way it sinks, the clay particle. So that means how much does it go on the side. You will know that in the laboratory there were some 2 brown plates that were put up. Now that's pores, and that means it's going to attract the water. Okay, so there the water goes through, which was in the beginning between the clay particles. The triaxial test, you saw that also last week. You don't need to know too much about this test, that's for the next block. Okay, the indicative soil table, that's coming from the European law. So here you can see, you saw that also last time, I showed it to you, which type of, let's say, property you can expect more or less for that soil type. More or less because we have to have a big spreading of the type of soil that you have and the properties that will come out. Was that soil already compacted before, etc.? There are things you can't find back in this table. Yeah? But that can have effects, of course, on the difference of those properties. You can also see it, yeah? Here you can see the variance coefficient, variety coefficient, 0.05, 5% differences, more or less. Here we come up to 25%. That's like a bonus, over 10. And then you have 10% and 20%. So you can see there is a big variance in the data that you have. So when you make calculations, this is good to make indicative calculations. You give a direction. Yeah? Is it absolutely the case? No. Also keep in mind with these values, we don't take into equation, for example, earthquakes, etc. And what I mean with that is, for example, in Mexico, you have to calculate 2.8 the weight. Because when you get a movement, you get actually the weight of 2.8 times that weight is going to push to something. That's depending for every country. So in the European norms, every country has different, let's say, factors for earthquakes, etc. But again, don't be bothered with it. You just need to know that you have to keep a little bit your second thoughts when you make the calculations. It's good as an indication. Alright? Keep that always good in mind. Dus mannen, die tabel dat je ziet, dat is inderdaad een Europese norm. Die dat we gebruiken, stond vroeger in een Europese norm, is er een tijdje uitgehaald geweest. Waarom? Omdat er eigenlijk een grote variatie is. Je hebt daar 5%, dat valt goed in, licht uit. 5% meer of minder, dat valt goed. Dan hebben we 25%, ja, dan is het een klein beetje, ja, je moet wat, kunnen we iets doen. Ja, links en haar. Ja. Daar situeert het zich. Ah, het is iets anders. Het is het. Het is niet links en haar. Correctie, het is de ja. En dan hebben we 10% nog. Nou, dat kunnen we een beetje beweren. En dan heb je nog 20%. Maar je moet wel beseffen, het is goed als indicatie om een idee te krijgen. Maar dat is natuurlijk niet goed. Zoals we hier duidelijk lezen, wordt veel toegepast bij een indicatie. En je hebt ook nog eens de factor van aardbeving in dergelijke. In Nederland is dat niet zo spectaculair uiteraard, maar als je Mexico en zo kan het op 2,8 zijn, dat je nog eens moet vermenigvuldigen met die waarde. Want op het moment dat je dus een drukverlies krijgt, dan kan dat een extra druk geven. Dan kan je niet alles van dat je probeert. Al het indicatief regelt.
Wat betekent het kleur van deze voorkant aan blauw?
Ja, blauw is een tabel.
Oh, oké, en heel erg op.
Ja. En wit is theorie, dan zouden we eigenlijk een beetje moeten weten waar er staat. Ik heb welke vragen over gesteld.
Die was ik er niet.
Ah, nee, dat is niet. Dus ja, dan moet je niet elkaar voorschrijven. Het is een andere gelegenheid voor ons. Okay, so the next table is like a very useful one. Okay, put it above your bed. Yeah. No? Take that poster of Britney Spears away. Alright, so you have, let's say, that table is very useful because when you get later in your life some input, some data about, let's say, you have the CBR value of 5%, yeah, cheapo, 5%, yeah, then you can estimate, oh, then the E dynamic will be about 50 MPAs. Your K factor, which is being used for concrete and more rigid pavements, to see what is the strength of the soil, you know it's about 35 or 38. The QC value EV1, EV2, and there are play tests, and you can also see what type of soil it could be. So when somebody says we have, let's say, a CBR value of 5%, then you know it can't be sand, because sand has a higher CBR value than 5. Yeah? That's why it could be useful sometimes to quickly compare. In a design they could say we have a sandy subsoil, and then they did lab tests, and out of the lab test the CBR value was 5%. No, not okay. That needs to be checked. Yeah? So every time when you see differences in results, you need to say like, stop, do it again, show me the results, show me a picture of the sample, because they don't match, right? So you can do different tests, but again, at the end, they should be more or less be in one line. Yeah? Okay? So, yeah, this is very useful. Dus mannen, dus die homogram noemen we eigenlijk, die geeft eigenlijk weer welke getalwaarde je kunt krijgen voor de draagkracht van een ondergrond. En ook welke grondsoort dat er overheen komt. Dus als je straks een CBR-waarde krijgt van 5% uit een laboratorium en die zeggen het is zandgrond, dan weten we dat kan niet. Want zandgrond dat is de S. Ja? En dan zie je daar allemaal klaarsoorten staan. Dus oftewel is dat CBR-is niet specifiek, ofwel hebben ze de verkeerde grondsoort doorgegeven aan
Dat
de
is dus,
CB
ja.
komt niet meer vrij, dat komt niet meer zat. Als je CB-waarde krijgt, gaat het 5%.
I need to stay at the front.
En ze hebben jou gezegd, dat je een klaar
If you notice, he gets very close to the seat.
En zo
He gets
is
very
ook
close to
een
the
klein
seat.
beetje
To the
afgehaald
microphone.
aan hetgeen dat ik hier ontvangen heb, klopt dat allemaal wel. Nooit niet uitgaan van, ik heb één resultaat gekregen en het zal wel juist zijn. Hè? Denk aan die dokter
Ja, ja, ja.
die er één resultaat krijgt en je zegt, ja, dus een ingrediënt in je lijf. Hè? Het is bepaalde dingen zegt. Die CBR is iets over de draagkracht. En die CBR-waarde, dat is de California Bearing Ratio, ik zal hem even uitleggen. En dat is eigenlijk, ga je kijken, vroeger in de jaren 30 in de Verenigde Staten, hebben ze ooit op stenen geduwd. En dat gaf zoveel indruk. En die hebben altijd onthouden. Hè? En nu, als je een klaargrond ook zo gaat duwen, op dezelfde manier, krijg je meer vervorming. Het verschil tussen die twee is de CBR-waarde, de California Bearing Ratio. Is eigenlijk één gedeeld door dat verschil. Zie je? Dus hoe hoger dat dan wordt, hoe kleiner dat verschil zal worden tussen die stenen in Californië toen en in Nederland. Right? So these values are telling us something about the elastic modulus or the bearing capacity. Yeah? All this data, what you see, except for the soil type, that tells us something that are all factors that are being used only to say something about the bearing capacity. So, in other words, also being said, the CBR value, it was a question. CBR, California Bearing Ratio. In the 1930s in California, they did a test with rocks, and they were looking how much is the soil going to sink when you put a load on it. Now, all the other tests are being compared. For example, when you have a clay test, you will have more deformation than with those rocks. The difference between those two, this is for the clay, this was for those California rocks. The difference between the two, that's our CBR value. Alright? And that's also a test that's being worldwide being used. Like the CBR value tells us something about the bearing capacity. Okay. Right, I'm going to talk a little bit more about it. CBR in the laboratory, EV1, EV2, the Germans, they like that a lot. But I will come to that right away. I'm just going to check it. Yeah. So, we discussed a lot of tests in the lab to classify soil, to test the capillarity, impermeability, blah blah blah, CBR value, etc. Now we go outside. We go on site, and the first thing what we will do is do a visual inspection. We're going to see how does the soil looks like. And what I mean with that is, of course, not like there's some grass and there are some sheets on it, etc. No, you have to look a little bit more thoroughly to the soil. Vegetation can say something. If you are in the desert, what do you see there?
Cactus.
Cactus. That's a nice desert that you have. Most of the time, not that much, not that good. And when you are, let's say, having more green and type of trees, then you can see also where the groundwater level is. And when it's, let's say, green at a dry period, then we know what type of soil we have. When it's a dry period and it still looks green, the soil, the clay, exactly, because you have a high capillarity, all for free, without have to dig something. You can directly see, okay, this is it in this type of soil. So in other words, when Google Earth was finally there in 2000 something, we didn't have to travel that much anymore because we could zoom in on Google Earth and look to Street View and see what type of vegetation is there. And then we knew already if it's clay or sand, etc. So it's very helpful. We don't have to travel that much to give an indication on the pricing, and the pricing depends for roads whether your subsoil is clay or sand. So that it's easy to check already what type of construction you must have. So visual inspections are very useful. Also, sometimes you can see where the groundwater level is. Like if you have, let's say, a canal next to it, or you have a river next to it, then you can immediately say, okay, there is a little bit that, of course, the groundwater level goes a little bit up, and near the river it goes a little bit down. But then you have also an estimation on the height of the groundwater level, because if we have to excavate, we don't want to do it in water. And we are. That's all the things that you can see with the visual inspection. Also check the existing buildings and existing roads. Because when you see cracks on buildings, what does that mean? Do we have sand or clay? Clay. All agree clay? So when we get, let's say, more cracks, etc., that's bad news. There is clay and it's consolidates. There is still, let's say, consolidation. On a road, when we see movement like this, then we can also see there must be some clay beneath. And then there are some tricks to see how deep the clay is. That depends on, let's say, the length of the waves. But that is a little bit tricky. But still you can see that. So a visual inspection tells us a lot. It's the same like you go to a doctor and he looks at you, he can also most of the time see a little bit like, might be this or that complaint. So when your right leg is full with blood, probably the problem is not on your left leg. Otherwise, it's glasses. Okay, it's the same when you look to soil, you can immediately see a lot of things. Alright, visual inspection, read it. A plate test. A plate is a very complicated test. You have a plate and you push on it, you see the deflection, and that's it. Very complicated. So basically what we're going to do is like EV1 and EV2 values, and that's something typical for the Germans. What they do is before they start building the next layer on a pavement, they do an EV1 or EV2 test. EV1 means you push on that plate on the soil and you get a certain deformation with a certain force. Then that's EV1. Then you take it off the load and then you push it back. And then the difference between the first deflection and the second one is EV2. That's EV1 and EV2. What is the advantage to do a plate test compared to a CBR test? What will be the advantage of a plate test compared to the CBR test? Who has an idea?
I'd say you could find the dynamic better if you did this one more than the other one.
Yeah, that's true. It can be very useful, but also when you do a CBR test, you grab some soil from the first 5 to 10 centimeters, and you're not testing what is beneath that 5 to 10 centimeters. With a plate test, you get back data from what is beneath. So what I can say is, for example, when you put, let's say, 5 centimeters of sand, and underneath that sand it's a very weak clay, you don't have the same property as a sandy soil in bearing capacity, because that soil beneath will have impacts. If you take out the sand, you test the CBR, and you say like, oh, it has a good bearing capacity, the subsoil. But with the plate test, you also check what is beneath that small top layer. That's the advantage of EV1 and EV2 measurements. Okay, with plate tests. Dus nou is dat duidelijk? Ja. Twee puntjes hier. CBR is alleen maar naar boven, wat is de standaard? Okay, hand drilling. When I started to work, I had my diploma and my graduation, and I had to go to do a first drilling test. And I had to do it with a person who was 63, 64 years old. He went just before his retirement. And yeah, it was, I was of course very eager. I wanted to learn things finally. After studying the whole time, I want to do something. And I thought, okay, drilling into the soil, okay, oh nice, let's start drilling. So I went with that older person together to that project location. And so I was ready, I put everything ready. He said, what are you doing? I said, yeah, I want to learn, let's start. upstairs. It's going to rain. Let's go to the McDonald's and drink coffee. So my first 3 days of my career was in the McDonald's here in Middelburg, by the way, because then they were building that location. It's very old already, but in that time. So I spent 3 days in the McDonald's because, yeah, it's cloudy. Nowadays we have to work. But in that time it was still like, the weather is not nice, then we stay inside. Also in the time when it was freezing, he told me, like when it was freezing outside, they had a bottle of Genever, kind of, yeah, I don't know how to say it in whiskey or something like that. It's not whiskey, but something like that. Vodka. This was also from grains. So, and then they drink it. It was very cold outside, and then they throw the bottle out. And if it broke, that means there was still ice. So then they know the next day we don't have to work. And when it didn't break, they knew like, okay, frost is over, the next day we have to work. Unfortunately, it's not anymore like that. Nowadays, it doesn't freeze that much anymore. That climate effect. Then, but in the time, it was all take it easy. That's why this type of test we're not going to do anymore that much. It's not all mechanical. You push into the soil, and based on the pushback that you get, the friction, it's all being measured. We can determine what type of soil is there. Unfortunately. But in the good old days, it was still take the soil samples out, and when it was raining, here, the hand drilling. So nowadays we do, sometimes you have seen these machines, paving. I don't know if you saw them before. So they put the needle into it, and they start pushing downwards to see what type of soil we're going to get. This is a sondation, as it called it. That's the result of a CPT test. Dus mannen, even voor jullie. Ja, dat stukje er wel van de McDonald's neem ik al. De whisky ook wel. Dat is wel. Nu doen we dat niet meer, want dat kost allemaal te veel geld. Ja, dus dan moet jullie wel enthousiasmeren. Hè? Dus je moet wel moet je enthousiast blijven. Het ding is, hè, dus nu doen we dat met een sondeerapparaat. Het CPT-test in het Engels. Inderdaad, goed zo. En die gaan altijd op je gsm staan. Dat is dus en niet anders. En in de man beoordeeld of niet?
Dat again?
Samen zijn. Anders slaat het goed. Ja, subsidie vooral. Ja, dat zal wel. Ja, dat kun je niet.
How? How do you do that?
Okay, so CPT-test is sonderingen. Dus dat
Ja,
gaan we
dubbel is
gewoon
dat.
een naaldje prikken. En door de weerstand dat ik krijg, door de wrijving dat we meten, zie je eigenlijk
This
bepalen
shoulder is
welke
taller
grond
than
dat
this
is.
one. I don't have masters in
Dat
this.
is net slecht weer enzovoort. Dus we zitten
Wow.
in een dus je moet
No, we don't.
en
And if I want to crack, then
vroeger
they
was dat
crack.
zo, dan werd er nog gewoon
Yeah,
met
how
de
do
hand
they do that? But if I want to crack them like
welke
this?
grond in
They don't crack. It's just they suck it hitting the bone.
Oh, then
It's not cracking.
yeah, it's not. It's just pain always. But
You have flat on your chisel.
Alright, so basically what you're going to get is like a plot where you can see what is the cone resistance,
show me again.
above cone resistance. Yeah. Then you have friction resistance and cohesion. And based on those values, we are able to determine what type of soil do we have at a certain depth. So, for example, when you see like a high cone resistance, which type of soil do you think it is? Clay or sand?
High what?
A high cone resistance. So you have that cone on the bottom of that nail that you push downwards. If you get more resistance, what do you think it will be? Sand or clay? Sand.
Sand, yeah.
We all agree? Sand creates, let's say, a higher. Yeah, that's sand. Here we are in a sandy layer. If you have piles, you have to drill them so deep that you come to that sand spot, and then they are well attached. Then, if it's on the other side, you can have peat. When it's very weak, it's peat soil. Now, to help you with that, we have some graphs.
What is called
Use.
resistance?
You
And
push
that is this one. And you
the
can see how it's in
nail or
Dutch,
the
but I
card,
will translate it for you to English.
the push back.
Take that it's not translated yet, but this is cohesion. The cohesion value that's the one was standing here in that sondation, that CPT result that you just saw. This is the friction number that you also saw. And then the third one is your cone penetration. So basically, you can see what is your type of
Why
soil.
don't you start from zero?
Easy peasy. Yeah?
That's your
Okay.
question.
I will give you some examples. Hè? Ja, maar die van je als is alles goed. Ja, goed? En dan laat je het namelijk eens weten welke afgekomen zijn. Dan moeten we dit gewoon gebruiken. Okay, so I will give you an exercise for that. So you can do it. Yes.
Why doesn't the graph start from zero? For the graph. They don't start from zero.
There. Yeah?
Yes.
Well, basically, good question. But the thing is like, you start actually with zero. However, you cannot have, let's say, because when you put the needle in the soil already, you start with a little bit of resistance. But that is not, let's say, counted, that you can evaluate already the soil. That's why we take a little jump where we
After,
start a little bit from the
okay.
zero. You can also have, let's say, like one big strong part, which could that be? So for example, when you have a sondation and you see this, when you would see this, what does that mean? What would that mean? Another layer,
Can
yeah?
you just say it?
What else could that be?
Dedans.
It could be a stone.
Stone?
Or could be concrete or some debris. Yeah. So sometimes when you see like very hard, you neglect it. That's why we're always going to use averages. Yeah. We don't say, oh, let's calculate it here.
Earthquake.
This point. We will always make it in blocks. Yeah.
This
And then we take more or less an average.
Mm.
Okay. You don't have to do it for every millimeters to determine the type of soil. You take it in blocks that you say more or less this would be the case. Huh? You can also see very nicely how, from a geological point of view, how the top part of the earth is formed. See on the top part where, let's say, in the floodings from rivers, and then there over there the sand that was of the time, it was, let's say, a sandy region here. Huh? So you can see how the earth was built up. Okay, guys. 10 minutes and we're there. 10 minutes. And then we have finished the theory and we can do some exercises. So, hang on. 10 minutes. Yeah?
You're bored? Don't even lie. Don't even lie. Go home like that.
I said I'm not dancing.
I can't believe you went home, came here and went. I mean, to be fair, he wasn't doing anything.
Alright, so settling measurements, when we do it on site, then it's what's quite simple to do is you put, let's say,
Where's 74? How do we go through slides
you
so
have the
fast?
soil, yeah? You put a slab on it,
You said read the.
then you have a stick on it,
Read, blah, blah, blah.
you put soil on it, sand, or just a load, and then you're going to measure, here. There is a sensor, and you measure how much it sinks. Yeah, that's a sand beacon, so you can test in the field how much the soil is consolidated with a certain point. It looks very cozy to me over there. You want to have something to drink, or is it looks very? I know. I think we need some beer or something. And something to eat. Just 5 minutes, 10 minutes, and then we finish.
I feel like we go home.
So, again, guys, sand beacon test. Yeah? You put a slab on the soil, you stick on it, then you put sand on it or loads. It's starting to sink, but then with the laser, you can see how much this sand is sinking. That is what we do. Alright? brandstof. Exactly, die handel en dat niet. We're already there. You can see some links on YouTube for tonight. It's Friday night, Friday evening. There's nothing
Maybe
nicer
you're
than
not coming
that to see
tomorrow.
some news about samples and soil
You're gonna
mechanics.
be busy man,
So
huh?
it's a nice present.
No, you're busy. Yeah.
Give you a
When I'm
nice
waiting for
movie.
you to tell me
The
when.
movie about pH measurements.
Are you paying?
Almost Oscar.
You are paying. When are you coming? When are you busy? That's my question.
Exactly what it's about.
It's like best for 2 years. Both of them.
Depends when you are busy. When we meet the guy.
It's in the afternoon.
Okay, an idea when you finish. I don't know.
1 hour.
Okay, guys.
4, 3. We want to meet at 3?
Okay, guys. Last thing about.
4?
We're not gonna eat.
You need to teach Nick how to make the food. So when you come, you have to wait for the food to get cooked. Remember that. Okay, perfect.
Okay. Last thing, some examples.
So
Here
close
it's
to
in the Amazon region. Ruku. It's a place for Petrobras, where they drill oil, and the idea is when all the oil is out, they give it back to nature. So the road that we build there is for a shortened period. So they don't make villages or cities, they don't let people immigrate, have children there, schools, etc. because then you never get rid of them, that's how it goes. So to avoid that, it's only a place to work. If you work, fly back to Manaus or some other place in the area, and that's it. In the area, it's about 500 kilometers. For the rest, there is
No,
no.
no, the battery.
So there you could see this is a very plastic clay. Very plastic clay, and that's the clay when you walk over it, every step you take, you're 1.5 centimeter higher. So you get very big there very soon. That place. But then of course because it's very sticky. So that is that type of soil. Also, what you will notice, I was there for 10 days.
Ah, that's cool.
And after 10 days you get really bored.
Oh.
Yes, because and also with the insects, etc., you have to do something in your ears, because otherwise insect can get into your ears. So it was 10 days like with things in my ears. So when
Headphones.
somebody says like the rainforest is very nice, no thank you. Not anymore for me, that's finished. There you can see also, like, let's say, the different types of chemistry of clay that you have in the Amazon region. You see, iron, limestone, etc. You have a bunch of mixture, and why that is important, because when you do a cement stabilization, you need to be aware that you can get different results every square centimeter. So that's how accurate it is. So in the case, if you have a mixed soil, due to the ages, due to the eras, the centuries, you can of course get different chemicals connected, all minerals. That's why it can grow very well. There you see that tent. That tent is being built. When you make something in sand, then you have to build a tent over the roads to build the roads. So you can see
That's a
it
tent.
costs a little bit.
Covered.
What
That is the tent.
Yeah.
In that tent, there was put a sandy soil. When it rains there in the rainforest, it rains very hard. It's like you take a shower. And then it's like 20 minutes or 30 minutes, but everything is. And then when you have sandy soil, you can do nothing for a few days.
No. That is the question. I wanted to ask, when it rains that hard, usually how much do you wait until the soil gets dry? Yeah.
How much I wait?
Yeah, but 3 days.
No, I didn't wait because we had a technique.
Oh.
We made a technique that we could mix in a product with the clay, and then we added the cement, and that became very hard. So we didn't need that method anymore.
So you just build it on the go.
Sorry?
You build it on the go,
Yes.
no stop.
Yes,
Okay.
non-stop. And when it starts raining, you just go with the compactor over the clay, so it's sealed off, and you make sure it drains to the sides. And then after that half an hour, it's just that top part that is really wet that you saw, but underneath it's dry. Well, more or less dry, but you can continue working. But when you would have sand, that sand is getting soaked because that water is getting to it, you can't do nothing anymore. Okay, so that's a technique that we used, and that's where we build all a lot of roads in the rainforest with. And then when you crush it, it's pH neutral, etc. That's for now not important, but it's just to know, be aware that soils are a little bit different sometimes. And the conditions that you're working are also a little bit different sometimes. So,
Smart method.
This one.
so here you can see with the technique that we use, nice clay. So when you mix it, it becomes more dry, the clay, because underneath that top part, which is very wet, you have, let's say, a more drier clay. And by mixing it, you create an optimum moisture content. And then you add some cement. There you can see that we use a sheep foot compactor, that one. And that's also when you have the clay parts, there are some lumps, some big fat clay parts. And by using a sheep foot compactor, you squeeze basically the cement and the product and the water through those lumps. So we use it also for mixing, not only for compaction, but the sheep foot compactor is also being used to basically mix it better. Ja. Dus mannen, dus in de regenwoud vroeger werden er wegen aangelegd. En daar waren verschillende redenen voor.
I love
En het klein is heel zwakke grond. Zeker als je met zware gewichten moet verrijden, voor dat bouwen van oliedeelmachines enzovoort. Dat neemt wel gewicht op. Dus hebben we dat er gebouwd. En wat je nu ziet, als het dan regent, is die toplaag zeer zwak, maar dat water kan je nog beneden dringen. Dus die grijwater relatief vochtig, maar
Do you love me?
dat is niet helemaal
Do you love me?
doorgewerkt. Maar je wel bij zand hebt. Dus als je dat met zand zou doen, moeten ze een tunnel maken onder luchtdruk. En dan wordt er luchtdruk ingeblazen, dan misschien ze luchtdruk buiten en binnen en dan staat die tent tegelijk op. Dus het is niet dat je hier zoveel kost of zo, maar je moet gewoon zien dat je verschillende luchtdruk hebt. Dan, vervolgens, zie je daar een schaapvoetwand, of een lokkenwand. En dat is ook aan die lokken om dat product een klein winkel te sturen.
Once more. He'll fall asleep if he's standing.
Die kleuren dat heel verschillend zijn.
Like he likes that.
Op dezelfde locatie kun je toch
Falling asleep if he's standing.
Dus vandaar door juist dat je die variatie in coëfficiënten zag.
I think so. We should.
Voilà, and that's the final result.
Whoa.
After finishing compaction, that is what you get. And you don't get, let's say, infiltration of water anymore, it's sealed off and that's it. Voilà. Finish.
Goodbye, Dimitri. I ran out of battery because of you.